Okay, good morning to you all. Before starting, let me share the screen. Okay, welcome to you all to the third lecture, and this is the concluding lecture under module 3. So let's quickly recap what we have done in the previous session. We have compared these components of Hadoop like MapReduce and HDFS with grid computing and volunteer computing. Right, in grid computing, that is actually called as high performance computing, where we come across distributed data distributed across large number of nodes, and there the data has to be transferred utilizing more bandwidth, which actually leads to network bottlenecks, right? But in MapReduce, instead of copying the data around, we transfer the computation to the nodes where the data is actually residing, so that we can save on this network bandwidths. Okay, and in volunteer computing, what we have done, and how we compared MapReduce to this volunteer computing. In volunteer computing, they normally divide the analysis work into smaller chunks called as work units, and those work units are transferred to various computers across the world who volunteer to donate their CPU cycles. But in MapReduce, we normally run the analysis tasks on dedicated systems, which are installed in a particular data center. And also MapReduce prefers data locality. Data locality in the sense data and the computation are co-located so that they can be performed on a single node without having to transfer data around. Right? These are the differences between MapReduce and volunteer computing. And also we have gone through a brief history of Hadoop. Now the topics to follow in this lecture are Apache Hadoop and the Hadoop ecosystem and Hadoop releases. Now, what falls under this Hadoop ecosystem? Although Hadoop is best known for MapReduce and its distributed file system, the term is also used for other family of related projects that fall under the umbrella of infrastructure for distributed computing and large-scale data processing. There are many other components, there are many other projects which can be put under this umbrella of Hadoop. All of the core projects are hosted by the Apache Software Foundation, which provides support for a community of open source software projects, including the original HTTP server. Now, what are the other projects other than HDFS and MapReduce? Though HDFS and MapReduce are the critical components, still there are other projects which are hosted under this infrastructure. First one we can talk about here is common. This is a set of components and interfaces for distributed file systems and general input-output. This normally uses serialization and also uses Java remote processor calls and persistent data structures. Serialization, you know what is serialization, right? Converting the data into objects and transferring them to whichever location they want, again reconverting it back to the data from object form. That is called as serialization. Now this common uses serialization and remote processor calls to invoke various processors on remote systems, and it also uses persistent data structures in order to store the data permanently. Next project is Avro. This is a serialization system for efficient cross-language RPC, cross-language remote processor calls, and persistent data storage. You can observe that in all these projects, most of the features are interrelated, right? But still, each one has their striking features. That is why they are used in different contexts. And the next one is MapReduce. We have seen about this already. This is a distributed data processing model and execution environment that runs on large clusters of commodity machines. And they handle error tolerance very efficiently. Or system failures can be handled very efficiently by using this MapReduce. And HDFS, Hadoop Distributed File System, it is a distributed file system that runs on large clusters of commodity machines again. But HDFS is normally used to store large volumes of data, and MapReduce is responsible for processing that large volumes of data. That is the difference. Now, another project is PIG. This is a data flow language and execution environment for exploring very large data sets. And PIG runs on HDFS and MapReduce clusters. PIG is like a top level query language, which actually is based on this HDFS and MapReduce. Means any PIG task will be converted in the background into MapReduce tasks, which use this HDFS in order to retrieve the data from this HDFS and perform the analysis process. And next one is Hive. This is a distributed data warehouse. Hive manages data stored in HDFS and provides a query language based on SQL. So it has derived most of its features from basic SQL, and which is translated by the runtime engine to MapReduce jobs for querying the data. So Hive is also like a query language. We call it as HQL, Hive Query Language. This is used to write queries at the top level, which are again in the background converted to MapReduce jobs and executed. And next one is HBase. This is a distributed column-oriented database. What is the advantage of this column-oriented database? In normal databases, you have to store a particular data according to a particular schema. Say if you doesn't have some data under an attribute, that has to be left empty. Or if you want to change the data type, once the data is entered, it is a difficult task, right? But in column-oriented database, you need not decide on the schema in the beginning itself. So what type of data you try to enter into the database, accordingly the columns will be created. That is the advantage of HBase. A distributed column oriented, this is a distributed and column oriented database, and also HBase uses HDFS for its underlying storage and supports both batch style computations using MapReduce and also point queries which perform random reads. That is why we can call this as a combination of RDBMS and MapReduce as well. Next project we can talk about is Zookeeper. This is a distributed, highly available coordination service, and Zookeeper provides primitives such as distributed logs that can be used for building distributed applications. Because you can build distributed applications, you may have to monitor all of these distributed applications without having any contradictions between the tasks that are performed. For that, they take care of providing distributed logs in order to synchronize all the applications running simultaneously. And the next project is Scoop. This is a tool for efficient bulk transfer of data between structured data stores such as relational databases and HDFS. Say some organizations, if they have RDBMS, the relational databases in place. Now all the data will be captured in relational databases. Now all this data, if you want to store at a higher level, if you want to store large volumes of such data, then all that data can be transferred in bulk to HDFS by using this Scoop project. And the next project is Oozy. It is a service for running and scheduling workflows of Hadoop jobs, including MapReduce, Pig, Hive, and Scoop jobs. Okay, this is like something like an interface where you can schedule all these tasks in a workflow. right from the beginning of taking the data, transferring the data, pre-processing the data, scheduling some jobs on the data, analysis jobs on the data, and consolidating the final results. All this set of tasks can be scheduled as workflows by using this OZ. Okay, now let us talk about Hadoop releases. Initially, the 1.x release series is a continuation of the 0.2 release series and contains the most stable versions of Hadoop currently available. This series includes secure Kerberos authentication. What does this Kerberos authentication do? It prevents unauthorized access to Hadoop data. Why? Because Hadoop HDFS hosts large volumes of data. Even security of that data, confidentiality of the data is also of utmost concern. That is why this series includes secure Kerberos authentication, which prevents unauthorized access to Hadoop data. Now the 0.22 and 2.x release series are not currently stable. Now let us see some of the features which are introduced by using this version 2.x. A new MapReduce runtime called MapReduce 2 is implemented in this on a new system called YARN. This is called as yet another resource negotiator, which is a general resource management system for running distributed applications. This is normally used to optimize the utilization of resources when MapReduce jobs are being run. And another feature is HDFS Federation, which partitions the HDFS namespace across multiple name nodes to support clusters with very large number of files. Say if there are large number of files that reside on the clusters, then single name nodes can't take up the task, right? So multiple name nodes can be used, and HDFS Federation monitors such partition of the name nodes. So this HDFS Federation, what it does is, it partitions the HDFS namespace across the multiple nodes, okay, in order to support large number of files fragmented across all the name nodes. And the third feature introduced in this version is high availability, HDFS high availability, which removes name node as a single point of failure by supporting standby nodes for failover. Actually, in older versions, there was only one name node, but here there are the other name nodes also implemented, which can take up the task of resuming the jobs once the primary name node fails. So this HDFS high availability ensures the name node, the secondary name node availability when the primary name node fails. So this removes the name node as a single point of failure by supporting standby name nodes for taking over when the failure occurs. Now these are the features supported by Hadoop release series. You can just see here, we have a table which includes details about 1.x version and 0.22 version and 2.x version. Here they discussed about features like secure authentication, which was available in 1.x version, but not available in the unstable version of 0.22, but again available in the latest 2.x version. And even old configuration names, whatever are available in 1.x version, they became obsolete in 0.22 and 2.x versions. So you may get some warnings indicating that these names of the modules are deprecated, or this kind of library is deprecated in this particular feature, in this particular version. And the next feature is new configuration names. New configuration names are, that's why, available in 0.22 and 2.x versions in order to cover these deprecated features. And old MapReduce APIs are available still in all the three versions, and even new MapReduce APIs are also available in all these three versions. Now MapReduce 1 runtime, which is a classic feature, is available on the initial two versions but not available in the latest one. And MapReduce 2 runtime, that is yarn, that is yet another resource negotiator, is not available in the older versions, but this is a new added feature in the latest version. And HDFS and HDFS Federation and HDFS High Availability. These two features are also not available under these older versions, but they are available in this new version. So the main features that are added in the new version are yarn, HDFS Federation, and HDFS High Availability, which still increases the efficiency and failure tolerance of this Hadoop while processing large volumes of data. Okay, we concluded third module now, and in the next class we are going to start fourth module, which actually is very lengthy, where we learn about the internal working of MapReduce and HDFS. So the classes should not be missed because we need to study about the internal infrastructure and the architectures underlying this Hadoop. So they are very important. You need to attend these classes compulsorily. Okay, otherwise it will be difficult for you to follow. Any doubt so far? I'll send you the assessments for module 2 and 3 also together. Try to finish them. Are you hearing me?
Yes, ma'am.
I'll send the assessments, finish the assessments, and I'll send the notes also. You can go through the notes and prepare for the exams, right?
Okay, ma'am.
Shall we end the meeting?
Okay, ma'am.
Meet you in the
Bye,
next
ma'am.
lecture with module 4. Thank you.
Bye, ma'am.
Bye.